Hello everyone, welcome to the channel. Today we are starting the chapter 6 review. Let's start it. So in the first question we have whether the function represents exponential growth or decay. So what was the concept? It is if you have a b power x or only b power x. If b is greater than 1, then it is a growth function. If b is in between 0 to 1, then it is a decay function. So here b is 1 by 3. 1 by 3 is less than 1. Therefore, this is exponential decay function. 5 power x. 5 is greater than 1. So it's exponential growth function. 0.2 power x. So 0.2 is less than 1. It's exponential decay function. You have to graph it as well. So see, I'm going to graph the first one. 1 by 3. And that's a decay function. You can choose some values. How? Let's see. I choose the value -1. At -1, you will get 3. At 0, you will get 1. At 1, you will get 1 by 3. At 2, it's 1 by 9. So similarly, it's go like this. Okay. At -1, it's 3. Then 1, 1 by 3, 1 by 9. So graph is going like this. This is the graph of 1 by 3 power x. The next graphs you can try yourself. Next question. You deposit $1,500 in an account that pays 7% annual interest. Find the balance after 2 years when the interest is compounded daily. So I'm solving the equation. The amount is equals to principal 1 plus rate over n to the power n times t. N is represented how it is compounded. Compounded monthly, daily, half yearly, quarterly, whatever. In our case, it's compounded daily. So n is 365. After 2 years, so t is 2. Percentage rate of interest is 7%, so R is 7%, which is 0.07. And the initial amount that is deposit is 1500. Substitute 1500 1 plus 0.07 over 365 to the power 365 times 2. Okay? You can solve this question yourself. It's just a calculation now. Now we have to simplify the expression. So if the bases are multiplying same and the powers will add. So it's 15. It's cancel. 10 2s are 22. E power 3 minus 6. So 3 minus 6 is -3. I can write 2 over e power 3. Power negatively, I can shift into denominator. Here, -3 power 2. It's 9 e power -5 into 2. It's -10x. You can write this or you can shift 9 over e power 10x. Because sometimes it's mentioned here, write in a positive power. So this is a power negative. I can write in a positive power by shifting in denominator. Next, we have to check that the function represents growth, exponential decay or something. So the term which has a power, look into that, e. E is a greater than 1. So therefore it's an exponential growth function. Next is the term which has a power x. It's a e power -x. No, it can be written as a 6 e power -1 over power x. So b is e power negative. So 1 over e is b. This is less than 1 or greater than 1? It is 1 over e. The number is 0.3. The number is less than 1. So it's exponential decay. The next is 3e power negative 0.75. Then whole power x. You don't have to include anything with x. Whatever the multiple of x considered as a b. So I'm calculating. It's a e to the power negative 0.75. 0.4. So 0.4 is less than 1. It's approximately 0.4, okay? So it's exponential decay. Okay? Then it says graph the function. You can graph it. Graphing for yourself. Okay? Evaluate the logarithm. For logarithm, we have some properties for the log. Log base a of a. Answer is 1. Log base a of 1. Answer is 0. So here log base 2 of 8. 8 can be written as a 2 power 3. So this is 1 and you're left with 3. So the answer is 3. Here log base 6. 1 by 36. 1 by 36 can be written as a 1 over 6 power 2. Again I can write log base 6. 6 power negative 2. So this turns to 1 and you left with negative 2. Log base 5 of 1, 0. Now we have to find the inverse of the function. How to find the inverse? For the question number 14, see. First you have to write fx as a y. So y equals to 8 power x. Now replace x with y and y with x. So x is equals to 8 power y. Now solve for y, or you can say isolate y. I can take log base 8 both side and will get y. This is the inverse of the given function question number 14. Now I am solving question number 16. It's y is already given. Replace y with x and x with y. You have to remove the log. The base of the log is 10. If no base is given, it means the base is 10. So here 10 power x equals to y plus 9 here. So 10 power x minus 9 is y. So this is the inverse function, okay? So next we can start, you can do 15. I'm writing the term here. You can try it yourself. X equals to ln y minus 4. E power x, y minus 4. So 4 plus e power x is y. Yeah. This is the inverse of question number 15. Next it says graph this 17 question. You have to graph y equals to log base 1 by 5 of x. There is a two ways to graph it. One is you can substitute the values of x and get the graph. The other is draw the graph of its inverse. And we know that the inverse graph will be, it's a reflection about y equals to x. So its inverse is 1 by 5 to the power x. So if I draw the graph of 1 by 5 to the power x, it will be this type of graph. Okay. And I have to take the reflection about y equals to x. Just take its reflection, how it looks like. It will be like this. You can draw it more convenient way like this. Okay. So this is the graph of 1 by 5 to the power x. Done? Next we have this. Describe the transformation. You see, e power negative x. So e power negative x changed to e power negative 5x. Then it changed to e power negative 5x negative 8. What is changed here? The term is multiply. X is multiply with 5. Whenever x is multiplied by 5, it's a horizontal shift and shrink. The number is greater than 1. So therefore it's a horizontal shrink. Horizontal shrink by factor In the case of horizontal, we have to take reciprocal. So by the factor 1 by 5. And the next is minus 8. Your graph is shifted 8 units down. 8 units down. Okay. In question number 19, log base 4x was there. Then what is the change? It is log base 4, x is changed to x plus 5. Then log base 4, x plus 5 as it is, and half is multiplied outside. What is this transformation? It's a 5 units left. What is the change? 5 units left. 5 units left, and then half is multiplied. What is that? Vertical shrink by factor 1 by 2. Vertical shrink by factor 1 by 2. If you still have a doubt in the transformation, you can watch the previous video where we have covered the transformation of exponential and logarithmic functions. Okay? Next, we have to write a rule for a function g. It's a vertical stretch by factor 3 followed by the translation 6 units left and 3 units up. What is the original function? E power x. So e power x is vertically stretched by factor 3. So that means multiply 3 outside. Translated 6 units left. Left means that the x is changed to x plus 6. Then it's a 3 units up. So outside 3 is added. This is your g function. Okay. We can try the next one. G is a translation 2 units down followed by the reflection in the y-axis of this function. So 2 units down means this changed to minus 2. Log of x minus 2. Then reflection in the y-axis. That means x changed to negative x. This is the g function. Okay? Now, we have to condense or expand according to this. What are the properties? Log x times y. If you have a two number, log a, b, it can be written as a log a plus log b. If the terms in denominator, log a minus log b. If the terms in the power, it's b log a. These are used for condensing and the right side used for expanding. In the first one, we have to expand it. So, it's log base 8 of 3x plus log base 8 of y. This 3x can be again expanded. Log base 8 of 3, log base 8 of x, log base 8 of y. Okay. Now I will do one condensing question. This 27. For condensing, make sure there is no any coefficient. If you have a coefficient, shift it back. So log x power 2 ln 2 power 5 minus ln 8. If I combine the first two, it's ln of x square into 2 power 5 into ln of 8. This can be written as a ln of x square 2 power 5 over 8. 8 is what? 8 is 2 power 3. 2 power 3. You can cancel with 2 power 5 here and you left with only x square and 2 square. Done? Okay? You can calculate another also. Try yourself. Next question. Now we have a change of base form. Here there are two types of log, either a common log or we can write in a natural log form. If I want to write in a common log form, it is a log 10 over log 2. This is common log form of the same thing. If I write in a natural log form, it's log 10 over log 2. Okay. You can try 29 yourself and let me solve for 30 question number. It's log of 42 over log of 23. This is common log form. Or if you want to write in a natural log form, that is ln of 42 over ln of 23. Okay. Next, we have to solve and check the extraneous solution. Solve means find the value of variable. The variable is x. How you can find x? Isolate x by taking log base 5 both sides. This is x. X equals to log base 5 of 8. This is number greater than 1, so no problem. Here, be careful. Whatever x you got, the x must be greater than 5 by 2 because the log is not defined for 0 and negative. So I want whatever x you got, it should be greater than 5 by 2. Let's solve it. It's log base 3, 2x minus 5 is equals to 2. I'm converting the logarithmic into exponential form. It's 2x minus 5 is equals to 2 power 3. It's 3 power 2. 3 power 2. It's 9, 2x minus 5. 9 and 5, 14, so 2x. X is 7. Done. Okay. Alright, so see this. Here, use the property first. Log of x times x plus 2 equals to 3. You can remove the log by taking exponential both sides. It is equals to e power 3. Let's solve this. It is x square plus 2x minus e power 3 equals to 0. If I solve this, I am getting two different values of x, negative 5.59 and 3.59. Here, domain of x should be greater than 0. Domain of x should be greater than negative 2. So we are getting the total, your x value should be greater than negative 2 and greater than 0. So basically we have to check a number greater than 0. This is the only number. This is extraneous solution. What is that? This is extraneous solution. But this is our original solution. Okay? Now, solve the inequality. Here we have to solve inequality. Taking the log base 6 both sides. X should be greater than this. No problem. X is greater than this. No any other condition because it's exponential. You can take 100, 1000, whatever, no boundary. Lower value you got. But here if you have log x less than equals to 9. I'm taking exponential both sides. I'm getting this. And it says x is less than equals to e power 9. And log of a negative is not defined. Log of 0 is not defined. So lower bound we have. We have the lower bound greater than 0. So I will write x is greater than 0 but less than equals to e power 9. Here you can take ln both sides. I take natural log both sides. Then 4x is greater than ln of 16 plus 2 divided by 4. 1 by 4 log 16 plus 1 by 2. This number is greater than 0 anywhere, but anyhow it has a no problem here. Either 0 or whatever the upper bound is. So you got this. Okay. You have to check the domain also. This is defined for everything. That's why I'm not getting any condition at the last. It's equality. But here log x has a domain x greater than 0 only. So therefore I write the lower bound here also. Okay. Next, write exponential model for the data pair here. This is y equals to ab power x. Substitute. Y is 8, x is 3. Y is 2, x is 5. You can divide both sides. 2 by 8, a b power 5, a b power 3. It's 1 by 4, b power 2. B is always a positive number, so b is 1 by 2. You got b 1 by 2. substitute b here. 8 is equals to a 1 by 2 power 3. That is 1 by 8. 1 by 8. So you got a is 64. Okay? Your a value is 64. Now you can try this question yourself. By taking top form, you can consider y equals to a ln of x, or you can write y equals to a plus b ln x. Use the calculator to calculate this. Now, a shoe store sells a new type of basketball. Show this table shown here. Use the graphing calculator for this. Remember in the last class we did use the graphing calculator, we find a logarithmic equation model. So we will use that same. Here you can check this. I draw the graph here again using the given points and I write a function. We got the corresponding a and b values. Okay, we will use these values in our equation model of the logarithmic. It's y. In our case, it's s is equals to 3.95 plus 27.48 log of t. We have to estimate how many pairs sold after 6 weeks. The time is given in the weeks. So substitute t as a 6. So ln of 6 plus ln of 6 multiply ln of 6 multiply with 27.48 plus 3.95. So I'm getting 53.18. So S is approximately 53.98. It's 53.18. But it is a number of pairs. It cannot be in the decimal. So you can take the number only 53. Okay. So 53 pairs are sold in a 6th week. Done. Any doubt? So you can watch the video carefully. If you have a doubt, you can ask in the comment section. We complete the chapter 6 with the review as well. In the next video, we will start the next chapter. Thanks for watching.